how it will be reflected. The same laws of reflection will hold good here also. This ray will be reflected. Now, if a ray is incident here, angle of incidence equal to angle of reflection. Similarly, if a ray is incident, yeah, the same law what we had earlier, the angle of incidence will become equal to angle of reflection. This is incident ray, this is a reflected ray. This is incident ray, this is a reflected ray. Incident ray, reflected ray. You need not to bother. Here also the angle of incidence will become equal to angle of reflection. Angle of incidence equal to angle of reflection. Angle of incidence equal to angle of reflection. Angle of incidence equal to angle of reflection. Let me define those thetas also. So this will be theta 1, theta 1, theta 2, theta 3, theta 2, theta 3. Angle of incidence theta 4, angle of reflection theta 4. So the same laws of reflection will hold good even for the spherical surface. Look at this, the reflecting surface is spherical. It's having wide application like plane mirror, no? Even this also will be widely used in the applications. Let's see that. Okay, now let's get into what are the best examples of the spherical reflecting surface. The convex and the concave mirror is what widely used in our day-to-day life. So what do you mean by convex and concave? So those surfaces we must have a better idea. First, let me focus on the. Okay, first look at this one. So I'll take a tennis ball, spherical ball. All of you know, lawn tennis ball it is. I'll take a knife. So this is the knife. So with knife, what I do is like I'm going to cut it into two parts. The parts need not be equal. The parts need not be equal. So when I cut it, so one of the part is get available. This outer surface, the green color one, what you see, that will become a convex surface. And the inner surface will be like some gray color it will be. So that will be in a concave surface. Or you do one thing, you can take a lemon, cut it. The outer part, yellow color layer of the lemon will be the convex surface. The inner part where the fiber and juice will be there, that will become a concave surface. Watermelon, same thing. In the watermelon, what happened again? You have to take out that red color edible part. So therefore, I'm just taking a tennis ball. So if you take a tennis ball, if you cut with a knife, parts need not be equal. The inner curved surface will become concave surface, and the outer curved surface is called as a convex surface. Got the idea? There's the one thing. Huh? Then convex mirror we'll discuss first. What do you mean by convex mirror? How to get a convex mirror? For that, what I do is like I will take a hollow glass, that one, hollow spherical glass, or so like a thin glass shell. Where the inner surface will be silvered and the outer surface will be available for reflection. Inner surface silvered. Okay, that one. And the outer surface will be available for reflection. What I do is like I'm going to cut it. Are you noticing this red color line? So let me cut this thin glass shell at this particular point. So this is the structure is what it will be available. I'll separate it. That will become a convex surface. Right? And this surface will be available for reflection. This surface will be I'll be using for the reflection, that one. Now the geometrical center of this mirror will become also like a geometrical center, like you can see geometrical center P will come here in case of this. Similarly, the geometrical center of the convex mirror, this is a convex mirror. This is a thin glass shell, hollow glass shell. This section will become a convex mirror. The geometrical center of convex mirror is called as a pole. Next, we have also C. So C should be the center. So it's a plain diagram. I assume it's a spherical shell, thin glass shell, not circle. Thin glass shell. The center of glass shell is what? We'll call that as a center of curvature. So what is the C? C will define it as I already pre-drawn so that we can save time, because other drawing such a diagrams, coloring will take more time. That's what before class only I had drawn it. Okay, fine. Able to make it out this one. So this particular structure now will become convex mirror. Okay, this will be the reflecting surface. Outer surface will be available for reflection. This is what the aperture of the mirror, what we call it. Later on, we'll discuss in detail. This is called like a radius of curvature. This is called like a principal axis. What is the principal axis? The line joining the center of curvature to the pole. So what is the pole? Usually how we define pole? Pole, we should define it as geometrical center of spherical mirror. The pole is defined as geometrical center of spherical mirror. Okay, now, so what is the principal axis? The line joining the center of curvature to pole of a mirror is called as a principal axis here. A best example, you take a spoon, a new spoon, a steel one. So my son, you can see holding, and I'm trying to take, I took the photograph. My son is holding. So now you can see that this particular thing will become a convex mirror. Very example, you need not to go to the big research labs, just spend some time in kitchen. So many things which are related to physics are available. So my son is holding this particular spoon. This particular, the bulged part of the spoon will be like a convex mirror. I'm just using, my son is just looking at the mirror, that one. I'm behind taking, I took photograph. So how come this is like a convex mirror? Or the rear mirror, which is used in vehicles to see the vehicles behind, no, there is nothing but a convex mirror. Just like some very good steel bowl or like a spoon of this one. So this is like a convex mirror. Getting the picture? Okay, now similarly, we have one more called like a concave mirror, where the inner surface will be utilized. The inner surface will be utilized for reflecting surface. So what I do is like again, I'll take a thin glass shell. I'll take a thin glass shell. I'm going to cut it at this particular part. Then the inner surface will be available for reflection. Reflective surface. Find this one. So I'm going to cut it. When I cut it, no. So the inner surface will be available for a reflection. So this particular structure, not this one, this hollow glass pair, not this hollow glass. This part of hollow glass now will become a concave mirror. Reflective surface, this everything now will become a concave mirror. So again, the P, what is the P? Pole. P, what happen? We'll call it as pole. C, center of curvature. What is R? Radius of curvature. Even the line joining the center of curvature to pole is called as a principal axis, which is very important. The inner surface is used for reflection. Here, this particular thing. So now again, my son holding the spoon, he has inverted. So he's holding it. Now I took the photograph. You can see that this part, this will be like a bowl, no? I think which surface will be using? This will be the inner surface of the spoon is what we'll be using, no? Here. to like and I think I'm from India, so definitely this spoon we'll use to serve the curries along with the rice or rotis or chapati, that one. So here is what that particular curry will be there. I think the diagram is very thin. So this will be the drawing diagram. Fine. So no. Which surface I'll be using? Why it is not going? Yeah. So at least no. I brought a spoon. So which is the? This will be concave surface. This will be the convex surface. Very simplified one. Or you can take bowl, curry bowl. It cannot be plastic. Okay, let this be steel spoon. Some utensils, curry bowl. So many examples are there. Just we have to just only look at this one. So this will be again convex surface. This is a concave surface. Got it now? So we have that one. So this was the inner surface will become concave. And I can now treat like you can see its image. Its image is there. So it's a mirror. So this will become concave mirror. If I look at this particular part, if my head is facing, if I face myself against this surface, so nothing but I'm using convex mirror, it will become convex mirror. If I'm here and trying to look at this one, if I'm trying to look at myself in the spoon, then nothing but what happen, a convex mirror will come into picture. The same thing with a bowl. This will be again a steel bowl. Like that, several examples what we can take. The objects around us also depend. We can treat like a convex and concave surface. Especially designed, we'll call it as concave mirror and convex mirror, which is widely used in applications. Got the idea? This one? So I'll show this. So this will be the concave. Sorry, convex mirror. Okay, then